So we have a region bounded by these graphs, and we want to revolve the bounded region about the x-axis and then find the volume of the solid of revolution. So this is the graph. This is the graph for y equal to x to the third. This is the line y equal to 0, which is also the axis of revolution. And this is the line x equal to 2. And when we revolve the bounded region about the x-axis, this is what the solid of revolution looks like. And just like before, what we do is we fill the bounded region with rectangles and then revolve each rectangle around the axis of revolution, and that will give us discs, and then find the volume of each disc and then add the volumes of the discs together, and that will give us the volume of the solid of revolution. And this is one of the discs corresponding to this rectangle right here. And the radius of this disk is just the distance from the axis of revolution, which is the line y equal to 0, and then up to the graph. And the graph is y equal to x to the third. And so the radius of this disk would be x to the third minus 0. This is the line y equal to 0. This is the graph y equal to x to the third. And so the radius is just x to the third minus 0. And x to the third minus 0 is just x to the third. And then the notice that the for this particular solid of revolution, x ranges from 0 to 2. 0 to 2. And so our limits of integration will be 0 and 2. And r sub x, which is the radius, which is x to the third. X to the third squared is x to the sixth. Antiderivative of x to the sixth is x to the 7 divided by 7. And then we evaluate from 0 to 2. So we put a 2 here. 2 to the 7th is 128, and then dividing by 7. And if we put 0 here, we just get 0. And so the volume of this solid of revolution is 128 over 7 times pi.